In this video, we're going to cover creating REST APIs in API Gateway using the AWS Console. Then we're going to develop our own REST API locally, test it locally, and then deploy it to AWS. But before we get into all of that, we're going to very briefly define what API Gateway actually is, just to make sure we're all on the same page.
Don't go anywhere. Don't go anywhere.
AWS describes API Gateway as the front door to your API. And after learning this, I was left with one burning question. What kind of front doors do they have? When a REST API is called in API Gateway, the request goes through a series of checkpoints before and after hitting the backend. At each one of these checkpoints, there is the potential for the payload to be either validated or transformed before the response is returned to the caller. Taking this all into account, I feel like I'm going to need a more sophisticated analogy than a front door to help me explain what's going on. I've decided to go with API Gateway as an airport. The payload for the request and the response will be us and our luggage. Just bear with me.
Don't go anywhere.
The first REST API checkpoint is method request. A couple of things we can do here is specify a method of authorization, similar to getting your passport checked. And we can also validate the format of the request by checking it against a data schema known as a model. If a request comes in and the headers, query strings, or body do not match the model that we've specified, the request will be rejected without it ever hitting the backend. A similar scenario takes place at an airport. If your bag weighs over the baggage limit, which is basically the airline's schema, you can either pay extra or you're turning around and going home, mate. The next checkpoints are integration request and response. These checkpoints allow us to transform the payload by using mapping templates, either immediately before or immediately after we hit the back end of the REST API. This means that the client request payload doesn't have to be in the same format that the backend is expecting as a method request, and the backend's response doesn't have to be in the same format as the one that the client is expecting for a method response. REST API's ability to facilitate loose coupling between the client and the backend can give us a good deal of flexibility when developing our APIs. Now, going back to the airport analogy, our backend is the plane and it requires people to take their seat without their main luggage, just their hand luggage. But the vast majority of people enter an airport, which will be our client request, and exit an airport, which will be our client response, with their luggage at their side. So it's clear to see that there are conflicting formats, and if nothing was done to alter the situation, people would be boarding the plane with their luggage on their laps, which is less than ideal. So in order to meet the format of the plane, or backend, our luggage is checked in before the flight at a checkpoint in the home airport, and we retrieve it after the flight at a checkpoint at the destination airport. The payload, ourselves and our luggage, is transformed before and after it hits the backend or plane. REST API also allows us to set throttling limits to protect our APIs from being overwhelmed by too many requests. Again, a similar approach is used by airlines, as they usually only let one or two sections of passengers board the plane at a time. And if everyone entered the plane at once, it would be absolute chaos. REST API also allows us to create usage plans that allow you to make your APIs available as product offerings to customers. Usage plans use API keys that can be configured to specific APIs. So you could have different APIs with different throttling limits. So you could offer a higher paying customer a more available API than customers paying a lower amount. In our airport analogy, you can probably see where I'm going with this one. Customers paying for first class can get a completely different airport experience than people with economy tickets. Not only do they get to board the plane first and have a luxurious flight, but they get to wait for the flight in a first class lounge that has free drinks and stuff. I mean, that's what I've heard anyway. I've only flown economy.
My dog stepped on a bee.
So I realized that they were not literally comparing API Gateway to a front door, and I wouldn't expect them to compare it to an airport because it sounds ridiculous. Let's have a look at what this looks like in the AWS Console. Okay, so here we are in the AWS Console. The first thing we're going to do is go to API Gateway. And if it's the first time you've come into here, you might see a screen similar to this. So just click Get Started. And as you can see, we can choose from 4 types of APIs: HTTP, WebSockets, REST, and REST API that are private. Obviously, we're going to be going for REST API today, so we'll click on Build. And we've got this little modal saying that we can use a pre-populated import for the pet store API defined using Swagger. We're actually going to use this just because we're having a look around and it will save some time. So let's just have a look at the default view, which you'd probably normally use. So we've got a choice between REST and WebSocket. We've got a choice between a new API. We can import from Swagger or OpenAPI free, or we can use the example API. We're going to use the example API today just to save some time. As you can see, we've got this Swagger document here describing an API, which we're going to import into our API gateway and go through some of the features. So for endpoint type, we've got regional, which means the API gateway will be deployed in the same region. We've got edge optimized, which means the API gateway will be deployed under CloudFront. And then we've got private, which means the API gateway will be behind a VPC. So we're going to choose regional and we'll click import. Okay, so this is the default screen and we've got a couple of prompts open. Okay, so we'll click off that for a second. And the first thing you can see is we've got the resources section, which gives us a tree of resources starting with the root. And you can see that we've got a pets resource sitting under the root. And then we've got a pet ID sitting under the pets resource. And sitting under the resources, we've got methods for the HTTP verbs. So for pets, we've got get, options, and post. And then we've got pet ID, we've got get and options. If you wanted to create another resource, you can come to actions and you can click on create resource. You can give a resource name, let's say owners, pet owners, and then we can create resource. And you can see we've got our new resource owners under the root. If you want to create a method under the new resource owners, we can click create method and then we can choose any HTTP verb that we want. So let's click get, and then we can define our backend integration and all that good stuff, which we're not going to do today. So let's just get rid of this while we look through the rest of it. So let's have a look at pets get method. And as you can see, it's got a method execution with some detail going on here. Now, these were what I was referring to earlier on as the checkpoints for the requests. So in a nutshell, the method request and response is for validating the request, and the integration request and response is for transforming the data. Now that's optional, you don't have to do that, but this is the capability that they provide. Now, why would you want to do either of those things? So let's take the method request first. You could create a public interface between the client, which we've got here, and the method request. What we can do on the method request, once we click into it, we can see that we can define authorization, which we're not going to do today. And then you've got this request validator here. You can see that we've got an option of none, which was set by default. We can validate the body, validate body query string parameters and headers, and validate query string parameters and headers. So what we could do is define a model. If we go to the model section here, okay, so if we wanted to have a look at some of the models that we've got, you can see that for pet, we're defining a model schema that wants an ID, a type, and a price. So for example, in our post request, if we wanted to create a new pet, on our method request, we could choose the body. So it's already got a model name of new pet, and we could request validate that the body should conform to a new pet. So currently that's set to none. So we could create a pet of any description. But if we set the request validator to ensure that the body conforms to our model, we could ensure that every pet that's created fits our model schema. Okay, so that's the method request covered. The integration request is for data transformation, and the integration request acts like an internal interface for the integration backend. Now, we haven't got any data transformation going on here. We're not going to use any in our example coming up, but we do have the ability to define mapping templates. I'll leave a link in the description if you want to find out any more about that. Today, we're going to use a proxy integration. So if we click into the integration request, you can see that this example is using HTTP. Our demo coming up is going to use a Lambda function, and we can choose whether to use a proxy integration for a Lambda function. If we just choose that, you can see we can use a Lambda proxy integration. And what this does is it injects the HTTP request into the actual event that's going to invoke our Lambda. So change that back to HTTP. And what a proxy integration would do for HTTP is proxy the request onto the backend, but it's not needed for this example. And then we've got the actual integration backend service that we're going to be calling. So in this example, AWS have set up a pet store API, and that is where this request is going to go. And there's not any transformation on the back end, and the response is returned with a model of pets. So all in all, the method execution with the data transformation and the request validation gives a developer a lot of flexibility, but that's saying that you don't have to use it. It's just there if you want to do it. Okay, so back to the pets get method. One other thing that we can do in the resources tab is actually test the API out without actually deploying it. If we go to test, I'm not going to fill any of the params out because I don't think we need any. And if we test it, we can see that we've just called pets and we've got the response body. So that's very handy. We can call our APIs without actually deploying them. And speaking of deploying our REST API, we can do that via the actions button. You can see that we can deploy our API here, and this is going to ask for a deployment stage. We don't have one at the minute, so we'll create a new one and we'll call that non-prod. And there you can see our API has been deployed to a stage called non-prod, and we've now got this invoke URL. So that is going to act as our base URL. So we can copy that, and in a new tab we can call the base URL, and then we can call pets doing another get. And as you can see, we got the same result we just got when we tested our API. So now that our API is deployed, we can call it outside of AWS. The stages section offers the settings we can adjust. We can enable a cache. We can specify throttling. We can look at the logs. We can also define the authorizers that we saw on the method request if we wanted to create them. I'm not going to do any of that today. We can specify some gateway responses. We've also got a dashboard so we can monitor how our API is doing. And as you can see, we've got the API call that I just made with the latency. And then we've got the usage plan that I talked about earlier in the API keys. So that's a whistle-stop tour of API Gateway. Let's develop one locally, test it locally, and deploy it to AWS. Okay, so before we get started then, there's a few prerequisites you need to do if you want to follow along with this demo. The first is you need the AWS CLI installed, you need the SAM CLI installed, you need Docker installed and running, and you could also do with the toolkit extension for VS Code. I've made another video where I explain how to install them, and I'll leave a link in the description to that. Okay, so to start off then, I've opened a folder in VS Code, a blank folder, and I'm going to generate a default SAM app with SAM init. I'm going to use the quick start template. I'm not going to use Python. I'm going to use Node.js. I'm going to use a zip. The hello world example. I'm going to enable X-ray tracing just so I can show you the requests going through the different stages. You should probably put no because you get a little charge for this. So you've been warned. I'm going to call this testing REST API. And we'll give that a second to complete. Okay, there we go. We got the testing REST API example generated. And here we got the template.yaml, which should look something like this. And what we're going to do is just going to get rid of the output section. And for this video, I am going to copy the resources section from a previous run through of this, just to save everyone's time, saves me typing it out and saves you watching me type. And then I'm going to talk you through what changes I've made and why they're important and stuff like that. So to start off with, we've still got the hello world function that the default app generated. Here you can see that. And I've changed the default API event that you get. I've changed it to be called get employees. And I've changed the path to /employee. The method is still get. And I've put a REST API ID with a reference of REST API. And I've defined that just above. So as you can see, we've got REST API, and that's of type serverless API. And then you should see some things that are familiar from the console run through. So we've got a stage name of non-prod. That means when we build our SAM app and we deploy it to AWS and it's all built and the resources are built, we'll have a automatically deployed API gateway under the stage name of non-prod. We've defined our endpoint configuration to be regional, and I've also defined a model for our employee. That requires a name, an employee ID, and the name's a string, and the employee ID is an integer. And I've also created another API event, and this one's called create employee. This one's got the same path, but this is a different method of post. And this is using the request model that we defined above. So this is saying that model employee is required, and we're going to validate the body. So we'll see that in action when we deploy it to AWS, and also just doing the reference of the REST API above. So that's all the changes that I've made. And I've also made some changes to app.js. So this is the handler for our Lambda function. So once again, I've made some changes from a previous run through. It just saves me typing this out. I'm going to leave a link to the app.js and the template.yaml so you can copy these over yourself if you want to go through them. So what have I done here? I've created an employees array with one employee called Bob. And I've also logged out the event. So once the handler kicks off, it's going to log out the event because we're going to have a look at this in CloudWatch later. We can see the Lambda proxy in action. It will inject the HTTP request into the event and we can have a look through that. I've created a result and we're looking in the if statement, we're looking for the HTTP method of get and the event resource of /employee. And similarly below, we've got a HTTP method of post and again the /employee. So the two paths that we just created in the template.yaml, and I am pushing in the event body if it's a post. In theory, we should be posting the employee model that we specified, and we're going to push that into the array. And then the results of both of these is going to attach the employee array in the response body, so we should be able to see our employees. Now, given this is Lambda and it's stateless, each time we run this, I'm going to lose the state of the employees that we add. As this is just a little example, obviously if this was production ready, we'd be using DynamoDB, so we could save the employees to a database, but this is just quicker for this example. Okay, so they're all the changes. What I'm going to do now is change into the directory with the template.yaml, and I'm just going to validate the template.yaml is still valid, which it is. And the next thing I'm going to do is actually run our API locally and test out the two API calls that we've just made. So let's test our API locally. It's great to have the option to test locally as it speeds up the development process. That means you don't have to deploy your changes to AWS every time you want to see if something's working as expected. AWS SAM offers two different approaches for testing locally, which both use Docker. The first approach is one I've covered in a previous video, link in the description, which was invoking your Lambdas locally. The second approach, which is what we're going to be doing today, is hosting our API locally, which we can then use to invoke our Lambdas in the way that we've defined. So for this, you need to have Docker running. I've currently got Docker running in the background, and the command that we need to run to host our API locally is sam locals start API. AWS SAM automatically finds any functions within our AWS SAM template that have HTTP API or API event sources defined. And you'll remember that we defined two API event sources. It will then mount the functions at the defined HTTP paths. So as you can see, our API is hosted at localhost port 3000. Let's open Thunder client, a HTTP client, VS Code extension, and test this out. So let's copy the URL from the output and append the employee path. Let's test the get method first. And great, looks like that's working fine as we get our default employee details returned. Now let's test our post method. I'm going to define a new employee called Hannah with an employee ID of 882. As you can see, we now get Hannah's details along with Bob's. Now there is a limitation with this testing. For example, let's test the employee model that we've defined. Remember that on our post to employee, we specified that a request model of employee was required and we specified validation of the request body. This will make sure that the request body conforms to our employee model. However, if we do the same call again, but we remove Hannah's employee ID, our request passes and the output is returned. Hannah is included in the employee array without an employee ID, which is not correct. The request body that we sent does not match our employee model that requires a name and an employee ID. We can see this in action later when we deploy it to AWS. So although this is not perfect straight out of the box, it is definitely a very useful tool at our disposal to save us some time. Okay, so now we know that the template.yaml is valid. Let's do a SAM build where we're going to build the artifacts that we're going to send off to AWS. And you can see we've got our build folder now. And what we're going to do is deploy it to AWS. So we're going to do SAM deploy with a switch of guided, and we'll just call it testing REST API, stack name. The region's fine. Happy with the changes we're deploying. Happy with the IAM role. Yes to this as well. We're okay with authorization not being defined on both routes. We want to save the arguments to a configuration file so we don't have to do this again. That name's fine, and there we go. So we'll just give this a minute to finish. And we just have to confirm one more time that we want to deploy the change set. Okay, so that's all finished, and it says our changes have been successfully deployed. So let's head over to AWS. Okay, and I'm back in API Gateway, and if I refresh, we can now see that we've got testing REST API, which is good news. And let's have a look at what we've deployed then. So we got the employee resource that we defined, and then we got the 2 methods that we defined under each event. So let's have a look at get to start off with. So we can look at the method execution for get, which is pretty standard. Take note that we've got the Lambda proxy integration. So this will inject the HTTP request into the event, which we'll have a look at in a minute. Okay, so after the integration request, we've got the Lambda, which is the actual backend that we're going to be going to. So let's have a look at that. As you can see, we've got our API Gateway event that triggers the Lambda. And you can see that we've got all of our code there. So it's looking good. Let's check out the post method execution. So as you can see, it looks pretty similar. But if we go into the method request, remember that we've required that it validates the body of the request. And you can see that the request validator has been defined there. And if we go to the request body, we can see that it wants a model type of employee. So let's have a look in our models to see if it's been defined correctly. And you can see we've got our model here. Let's have a look at the stages. We've got a staged by default, and then we've also got non-prod, which we requested. Let's have a look at that. And as you can see, we've got our, similar to what we saw in the console example, we've got the invoke URL. So I'm just taking the invoke URL. And we're going to call obviously the employee path with a get request. Bit squished, but you can see that we've got our employees returned. And remember that we only had 1 in the array. So what we can do now is try our post method that we did. Okay, so we got a name of Fred. And we're going to give him an employee ID of 456. Okay, and great, that worked fine. You can see that we've got both Bob and we've got Fred as in our employee array. Okay, so let's test out the request validation that we set up, and let's leave out, create a new employee called Jeff, but we're going to leave out his employee ID and we'll see what happens. So we send that off, and then we get invalid request body. So our validation on our method request has worked. What happens if we give him a employee ID of 789? We give him an interest of reading. And you can see that it's worked, that we've actually inserted the employee into the array because our required fields have been met. And we don't really care about his interests, but we're happy to include him. So now that we've confirmed that's all working, let's go over to CloudWatch and see what's been going on behind the scenes. Okay, so here we are then in the log groups of our Hello World function that we just created. We're going to have a look at the logs that we've just made based on the requests I made from Thunderclient. So here we can see that we've got the console logged event that I put in. If we come down to the bottom, you can see the final post I did with Jeff. If we come down, we can see that we've got the Jeff employee and then got the interest of reading. But you can see that the Lambda proxy has injected the HTTP request into the event. So you can see all the headers and the multi-value headers, that kind of stuff. That's available within the Lambda function for you. So it's good to know, could be useful. And the final thing we're going to cover is just quickly have a look at X-Ray and have a look at the requests that we made and its journey through AWS. I take the latency and stuff like that with a pinch of salt, but it's more about the journey it took. I'm going to do another video on the HTTP API. It's a good way of comparing and understanding the differences between them. Okay, so that's how to create REST APIs in API Gateway. If you enjoyed this video, give it a thumbs up and I'd be grateful if you could hit subscribe and drop any comments you've got down below.